Experiments involve a deliberate intervention in the environment in order to observe what happens to a response variable. We do this so we can ascertain if there is a cause and effect relationship between the explanatory variable and the response variable. And the best way is to conduct a strong experiment. But sometimes this is not always possible. That's why we're going to spend a few minutes talking about quasi experiments. The unit that is randomized to conditions is called the experimental unit. If we randomize students to a control and treatment condition, the student is the experimental unit. If we randomize patients with a particular disease to control and treatment conditions, the patient is the experimental unit. If we randomize school districts to a treatment and control, the school district is the experimental unit. In true experiments, the unit of analysis and the experimental unit are the same. If they are not the same, this is called a quasi-experiment. Quasi-experiments are needed when the unit of analysis cannot be randomized to conditions. So I've just shown you or told you how you can determine if it's a quasi-experiment. If the unit of analysis and the experimental unit are the same, when the researcher is intervening in the environment, it's a true experiment. If they're not the same, it's a quasi-experiment. Here's an example. A researcher wants to test an intervention in a real school setting. She obtains permission from the district and several principals, yet she is not allowed to pull students out of their normal classes. To handle this, she randomizes classes to conditions. Now, what is it that we're actually measuring here? Who are we actually observing? We're observing the student. We're collecting data from the student. So the student is the unit of analysis. But what did we randomize to conditions, the treatment and control? An entire class went to the treatment condition. Actually, multiple classes went to the treatment condition, and entire multiple classes went to the control condition. So the experimental unit is a class. Those are not the same. Therefore, we're talking about a quasi-experiment. A researcher can change a quasi-experiment to a true experiment by changing the unit of analysis. The consequence of this is a smaller sample size, so there are less replications. So there's a price for making this decision. So for instance, in the last example, where the researcher randomly assigned classes to treatment and control conditions, let's suppose that there were 6 classes, 20 students per class. That would be 60 units of analysis. 3 classes were randomly assigned to one condition, 3 to the other. So we have a quasi-experiment. But instead of looking at student scores, if the researcher took a score for each class, like maybe the average of the class, and used that as the score, then this would be a true experiment because the experimental unit would be a class and the unit of analysis would be a class. So it would be a true experiment, not a quasi-experiment. But the penalty is we only have 3 classes in each condition, so we'd only have 3 scores in each condition. So we only have really a sample size of 6 for our analysis instead of 60, or 6 times 20, which would be 120 for our analysis. The primary questions to consider in the decision are, how small will the sample be? And if I go ahead and stick with an experimental or quasi-experimental design, can I have a strong one? Well, what do we mean by that? Strong quasi-experimental designs are those that use clever techniques to address extraneous variables. For example, there's a technique called counterbalancing. The way that works is that, let's stick with our example, and let's suppose we have 3 classes assigned to the treatment and 3 classes assigned to the control, and we're studying different instructional methods for teaching science. What counterbalancing does is halfway through the study, you swap which classes get the treatment and which classes get the control. If we then find that the classes with the treatment before swapping had higher outcomes, and the classes with the treatment after we change classes had higher outcomes, then we can say that there's probably a cause and effect. Not for certain, because it's not a true experiment, but probably. We're not going to go through a lot of quasi-experimental designs. I just wanted you to have a sense of what these are and to know that they're sort of halfway on the way. They're better than observational studies, but not as good as true experiments, because the only designs that can lead to a convincing conclusion about cause and effect are true experiments. Well, I've given you a lot of concepts in a short amount of time, but this has all been about how collecting research data leads us to make different statements with our conclusions when we do a statistical analysis. We talked about how to obtain the units to study, that is, how to start with a population that's accessible, and from that choose a sample. And the way we choose a sample will determine who we are representing and therefore who we can draw our conclusions about. And then we talked about obtaining data from the units, either through an observational study or some sort of experiment, ranging from strong experiment to quasi-experiment down to really weak experiments that we should never use. Now, how do these things interplay? How do we look at types of samples, for instance, combined with types of experiments? The type of sample that we have will determine who we can conclude for. That is, who is it that we're able to give our conclusion about? If the sample is representative of a broader population, we'd like to draw conclusions for that population. But if we have a convenience sample, then the conclusions can only be about a more specific group of individuals. Well, if we have a true experiment with, say, a convenience sample, not all is lost, because a true experiment will help us ascertain cause and effect. What are we going to have to do you think, in order to see that cause and effect that we found with that convenience sample applies to a larger group? I suspect you might have guessed it. We would have to do the study again, maybe with a different type of sample, or if we're stuck with convenience samples, another one. That is, we would replicate the study. And the more that we can replicate the study and get the same cause and effect outcomes with a true experiment, the more we start to believe that we're onto something, that we have a general cause and effect principle. So that's why I say that even with samples that are not representative, if we can in fact ascertain cause and effect, we can say something important. We'll just have to replicate in order to strengthen and broaden those conclusions for a larger group. Conversely, if we have a nice representative sample, say we've done a simple random sample from a pretty large accessible population, and let's say we do an observational study. The observational study will give us some decisions about association, not cause and effect. It might suggest cause and effect, but it will tell us about association of variables, and we can claim that association of variables for the larger population that is represented by our simple random sample. Obviously, if you think about it, the best of all worlds would be to have a very representative sample, like a simple random sample from a large accessible population, and a true experiment. That's often difficult to do. Often researchers have to compromise one or the other of those, either their sampling or the way they design their study to see if they can ascertain cause and effect. In my world, I would rather give up the representation of the sample and be able to have a true experiment to ascertain cause and effect and then replicate. I'd rather have that than to have a more representative sample, but all I get to do is not look at cause and effect, just look at association. And the reason that I say that is because the whole idea of science is to ascertain what variables are affecting or influencing what other variables so that we can control our environment.